Dear students, welcome back to my channel Classless. Myself Suprabh Srivastav. We have started a new series for solving the questions, all the questions from HC VERMA, and we have picked up the chapter Introduction to Physics, which is the very first chapter of your 11th class physics. So we'll be solving today two questions from exercises. Okay, so only two questions because this will make our video shorter and will be easily seen by our viewers. So students, questions from exercises is like this. That first question is saying that find the dimension of linear momentum, frequency and pressure. Three questions in form of parts A, B and C are given. Okay, first question is saying that we have to find linear momentum's dimensional formula. So first we will write the basic formula of linear momentum. So we all know about the basic formula of linear momentum. What is it? P equals to mv, where P is the symbol for linear momentum. So I have written the formula. Now I will be putting the dimensional formula of each basic quantity of the given formula. Like the dimensional formula of mass is m and dimensional formula of velocity is L t minus 1. Okay, so this will make our answer ml t minus 1. And if there is confusion from where I have written the dimensional formula of velocity Lt minus 1, you can see here. You will be writing a basic formula of velocity, which is velocity equals to displacement upon time or d upon t. In abbreviation, distance I will be using L, and for time I will be using t, dimensional formula. So I will be writing dimensional formula for velocity Lt minus 1. That's what I have placed here to create formula for linear momentum. Okay, so this is your answer. Now we'll be moving towards the next part, which is B part. What B part is saying? B part is saying you have to find dimensional formula of frequency. So frequency, you know that frequency, if I denote it with n, then the formula is 1 upon time period. We know very well about this formula. So now I have to write dimensional formula of 1 upon t. So as we know that 1 is a dimensionless quantity because it is a constant value, so it has no dimensional formula, but I will be writing like this: ml m to the power 0, L to the power 0, T to the power 0 upon here's time. So time is having dimensional formula T. After solving, I will be getting T minus 1. Okay, so this is the answer for your B part. Okay, because this whole value is nothing, only T to the power 1 will go up and it will convert into T to the power minus 1. Okay, next part, C part. What is it saying? C part is saying to find dimensional formula for pressure. So I will be writing formula for pressure, P equals to F upon A. Now I will be writing dimensional formula for force, which is mlt minus 2. If you know, if you don't know, I can find it. Just wait for a while. Area of anything, you can write it L square, means side square. Okay, so after solving, I will be getting ml minus 1 t to the power minus 2. That is the answer. If you are having confusion how I took the value of dimensional formula of a force, so you can look here. I can use the basic formula for force, because if you are a little bit confused about how I wrote mlt minus 2, so you can see here how I am finding the dimensional formula for force. I will be using very basic formula, F equals to ma. We all know about this formula. If you don't know, then remember it. F equals to ma. M is very basic, that is a basic physical quantity, so I will take is as it is. Now acceleration is velocity upon time, m. Now I will be reducing velocity into one more step, like simpler formula, distance upon displacement upon time. So it will look like distance upon time means distance upon time is square. So I can write here the dimensional formula, because I have the quantities which are very basic in nature, m, distance l, and time t square. So this can be written as mlt minus 2. So that's how I've written the dimensional formula of f like this. So if you remember, because these formula are very important and very easy, as you can see, so you have to learn it at your tip, so that you can use it quickly. Now the answer is this. Now we are moving towards the next question, that is second question. What second question is saying, it same thing is happening in this question. Find the dimensions of, we have to find the dimensions of second a part, angular speed omega. Angular speed omega. So first we'll be writing the formula for omega. We know delta theta upon delta t. You can write theta upon t, angular displacement upon time. Now angular displacement has no dimensional formula, as we know. So I'll be writing m to the power 0, l to the power 0, t to the power 0, and time will be written as t, because it has dimensional formula t. Okay, now I'll be solving this. I'll get t minus 1, which will be the formula for angular velocity, angular speed. Now the b part, what b part is saying, we have to find angular accelerations formula. Okay, alpha. What is the formula for alpha? Delta omega upon delta t, rate of change of angular velocity. Okay, that means you can write it simply omega upon t. Now I have found the answer for omega, that is t minus 1, and now time is also t. I have written the value dimensional formula of omega from the last part, where we have obtained the dimensional formula of omega. So from there I have used it, I have used directly. So after solving I will be getting t minus 2. That will be, these are very easy questions, t minus 2. Now this is the answer for the second part, because we have got the answer. Now C, what C part is saying, we have to find dimensional formula for torque means torque. You have to write the basic formula for torque, which is F cross R of F multiply R. F is force, so we have obtained the dimensional formula for force, and also we know that it is mlt minus 2, and R is a distance, so I can write it as L. After solving, L will be adding the power of L, ml square t minus 2. That will be the answer for torque. Okay, now D part, moment of inertia. So we know that the formula for moment of inertia is mr square, where m is the mass and r is the distance. So now I will be writing m for a small m, that is mass, and for distance l, so square of l is l square. So it will look like ml square, and that will be the answer. That will be the dimensional formula for moment of inertia. So students, that's all from my side for this video, and we'll be solving other questions in next later videos. Thanks a lot for watching. Thank you.